how your Oracle utilizes memory. That is what your Oracle's architecture. For example, I'm having some 8 GB RAM. My total RAM is, let's take 16 GB. My total RAM is 16 GB. So I want to install operating system in this system. On the top of the operating system, I'm installing Oracle database. On top of that, I'm installing my application. I want to install three big things. One is operating system, second one is a database, third one is your SAP. So can I give 16 GB to operating system? No. So what I'll do some memory to operating system, okay, some memory to my Oracle, some memory to my SAP. Let's take 4 GB, 4 GB to my operating system. What is that? Operating system. And 6 GB to my Oracle database, DB. Here my database is Oracle. And 6 GB to my SAP. 6 GB to my SAP. 6, 6, 12 plus 4, 4, 16. Yeah. This is how I need to give at the time of installation of that operating system, database, and your SAP. Now, Oracle architecture means today I am talking about only how Oracle is utilizing the memory. This part. So 16 GB RAM means I am talking about what? Memory, physical memory. Memory means your RAM. How it occupies your memory. When you start application, to start any application, you need a instance. You know that, right? What is the meaning of instance? RAM memory plus few processes you need to start. The same way, when I am starting my Oracle database, it will occupy some memory from your RAM, whatever memory you have given, and it will start some background processes. When it comes to SAP also having some memory areas, right? Role memory, extended memory, heap memory, and some background process like dialog, background, update, spool. These are the process of SAP and the memory structure. And when I start my Oracle database, that also occupies some memory, plus it will start some processes. What are that? We'll see today. Is it fine? So Oracle's architecture means how Oracle is occupying memory, how Oracle utilizing your RAM. That is what Oracle's architecture. This content. So now I'm discussing about this 6 GB. According to this example, my memory is what? Oracle memory is what? 6 GB. So I'm only talking about this 6 GB RAM today. This is that 6 GB RAM. That is called as SGA, System Global Area. What we call it as? System Global
Global.
Area. Where you have System Global Area information? In which file? When I start my Oracle database, first what it will read? First file. Anyone?
Different.
P file, right? P file contains memory configuration information, right? What is the P file location, guys? Oracle, Oracle home,
Oracle home data.
Oracle home.
Oracle
Under
database.
that, you will be having database init sid.ora. This is my P file. First, the system will read this file. So, what it is having? This file, system global area parameters, SGA. What we call it as? SGA, system global area. These all parameter files are called as system global area parameter. How see DB block size 8 KB. We discussed, right? DB block size is 8 KB. Our database DB block size is 8 KB. Shared pool size, that pool size, this pool size, everything will be there. So all these parameters are related to your system global area. Now it will read that parameters. According to that parameters, it will occupy memory. Total memory of system global area is what? 6 GB. That 6 GB again divided into buffer cache, Redulog buffer, shared pool, large pool, Java pool, stream pool, and fixed SG. Means you'll be having some memory for buffer cache, Redulog buffer, shared pool, all these memory areas. If you add all these memory areas, the total will be 6 GB. When you start your Oracle database, it will occupy 6 GB of RAM memory. According to this example, not exactly 6 GB
But
all the times. If you give 10 GB
that's
for
really
Oracle, it will, okay, wait. It will occupy 10 GB. If you give 6 GB, it will occupy 6 GB. So, if you add all these memory areas, the total will be your system global area. That the buffer cache size, Redulog buffer is equal to size, shared pool size, large pool size, all these sizes are written in your P file, parameter file. First, the system will read this P file and it will occupy the memory. This contains buffer cache, Redulog buffer, and shared. What is this RAM or hard disk? These memory areas are
RAM.
RAM,
RAM.
exactly, not hard disk, right? In a hard disk, whenever you do transaction, I told you what happens. Data will generate, right? Along with the data, redo entry also generates. Redo entry. So the data will go and save in buffer cache. Redo entry will go and sit in redo log buffer. So directly it won't save in your hard disk. In hard disk you'll be having what files? Data files and redo log files. These are where you will get these files in a hard disk, right? So if I create one sales order, first that sales order will be created in your RAM. For example, I'm writing something here. Where it is saving now?
RAM.
RAM, right? When I say file save as JPG image, now C drive. For example, if I give desktop also my C drive now. If I say save, now it is saved in my C drive, hard disk. So till that time, it is storing in your hard disk RAM only. So whatever you do transactions, first it will be saved in your RAM. Then only later it will go to data files and redo log files. So if you create one sales order, where it will be created, that sales order? Sales order will be created here. Exact sales order created here also. Redo entry. Later, this data will go to data files and this redo entries will go to redo log files. Is it fine?
Yes, sir.
Yeah. So in SAP, we are having some processes. What are they? Dialog, background, update, spool, and enqueue. These are application related. Today we are talking about database. Database also an application which is also having some processes, just like dialog, background, update. In database also we are having some processes. What are they? DB writer, log writer, checkpoint, smon, and pmon. These are the processes of your Oracle database, mandatory process of Oracle database, just like your dialog, background, update, spool, and enqueue that are related to your application. These processes are related to your database, Oracle database, not all databases. Remember, DB writer, log writer, checkpoint, smon, and pmon. The RAM memory plus processes collectively called as what?
Distance.
Instance. This processes needs to start and this memory has to be allocated. Then only you can access your tables, table spaces, whatever. Oracle application starting means what? RAM memory has to be allocated plus this processes needs to be start. That is what we call it as Oracle instance. See, I'll show you the image. See, this your database will have two things. One is a logical thing, second one is physical thing. This logical thing is memory. My screen is visible? Memory. And physical,
Yeah.
what you have in a hard disk, your data files, log files, archive log files, these are all belongs to your hard disk. And database instance means your memory structure, means your buffer cache, redulog buffer, shared pool, large pool, steam pool, java pool. This sga, total sga plus some processes, db writer, log writer, checkpoint, smon, pmon, collectively these two collectively called as instance. Who will give these processes? Your processor will give these processes. Who will give this memory? Your RAM will give this memory. So combination of your processor and RAM to start up any application is called as a instance. The startup processes, the core processes, auxiliary processes which are used to start your application is called as a instance. Can you start any application without starting instance? Instance is what? For example, VLC player is there. To start that VLC player, some memory has to be allocated and one background process needs to be start vlc.exe. The combination of that two is called as VLC instance. The same way for Oracle also, the combination of these processes plus this memory areas, SGA, total SGA, plus these five processes collectively called as a database instance. Once this memory is allocated and this process is started, now you can access your data files and log files. You can read without starting these two only. Okay, can I read my tables like this directly? Can I read my tables here? See, Oracle, this is file structure. Just I can see the files. I cannot read what I have in this. Just I can see the file, but I cannot read this. For example, if I have some .doc file on my desktop, can I read that .doc file without starting my MS Word? No. The same way, these files I cannot read. Just I can see that file, but I cannot read. If you want to read the data what we have in that, you need to start that particular instance. What is that instance? Your Oracle instance you need to start. The combination of memory plus processes collectively called as an instance. Once instance is started, then you can access your data files, log files. By using that instance, you can open the tables, table spaces, segments, everything. But directly, you can only see the files. Now, this memory areas is having few things: buffer cache, redulog buffer, shared pool, large pool, java pool, stream pool, and fixed SGA. So total size is 6 GB. So if I create a sales order, first it will be saved in your date here and exact copy will save here in RAM. Later, buffer cache information will go to data files. Redulog buffer information means this RAM information will go to your Redulog files. From this RAM information, it will go to data files. Who will write buffer cache information to data files? Who will write Redulog buffer information to Redulog files? Here, DB writer. DB writer. There is a process, right? This DB writer is responsible for writing buffer cache information to data files. Log writer is responsible for writing Redulog buffer information to Redulog files. If DB writer and log writer is not running, then no information is updated to your SAP data 1, data 2, data 3, data 4 and Redulog A and Redulog B. Who is writing to these data files? Here we are having some data files, right? In a hard disk, we are having some data files. Who is writing all this content to your data files? Data 1, these are your data files. Data 2, data 3, data 4. Who is writing? DB writer. Who is writing to these log files? Log writer. So first, where this data will saved before coming to hard disk? In the RAM, Redulog buffer. This data before coming to Orilog A and Orilog B, Redulog buffer. from RAM's Redulog buffer to Orilog A, Orilog B. From RAM's buffer cache to data 1, data 2, data 3, data 4. Is it clear? Who is writing data files? DB writer. Who is writing log
DB
files?
writer.
Log writer.
Log writer.
Okay. Here my question is, when DB writer will write buffer cache information to data files, when this log writer will write Redulog buffer information to Redulog files. If you understand that enough, you will understand all the backup, restore, recovery concept. Wait for 1 minute, I'll share the screen. Now I'm talking about, okay, forget about all these memory areas. Only now I'm discussing about this buffer cache. Only buffer cache. Now I'm sharing one screen. See what we have in that buffer cache. This is my buffer cache. That area. This buffer cache, we are having three things: free buffer, pinned buffer, and a dirty buffer. Free buffer, pinned buffer, dirty buffer. Dirty buffer means committed data. For example, you created 5 sales order. That is comes under dirty buffer. Already committed. Data is committed. My screen is visible?
No, on screen.
Now?
Yes.
I'm talking about only that buffer cache. That buffer cache contains a free buffer, pinned buffer, and dirty buffer. Dirty buffer means committed data. You have booked some 5 mobiles. 5 different customers have booked 5 mobiles. The transaction got successful. That is called as a committed data. That is called as dirty buffer. And 5 people are trying to book some mobiles. Means they are entering all their bank details. They haven't entered the last OTP. That is called as a pinned, written yet to commit. This is committed data. This is written yet to commit. Free buffer means nothing is written there. Is it clear? We have 3 things in buffer cache: committed data, written yet to commit, and free area. No data is there. So completed transactions, yet to complete transactions, and nothing is there. 3 areas are there. And which one it will write to data files? Only committed data, the final data, the original data has to go to data files, right? I'm entering some wrong bank details. If you enter that details into your data files, that is wrong data, right? So only committed data from buffer cache has to go to data files. Yes or no? Your sales orders created, that data only has to go to data files. So this DB writer will write only dirty buffer from buffer cache to data file. This buffer cache contains free buffer, pinned buffer, dirty buffer. Only dirty buffer means committed data will go to data files. When this DB writer writes when, please, disabled. Okay, when this DB writer writes, the first thing is when 1/3 of buffer cache is dirty. That means what? This buffer cache, for example, this buffer cache size is some 1 GB. Total is 6 GB, right? Total memory is buffer cache size is 1 GB. So almost 800 MB is having committed data. Then DB writer will write that information to data files. Second one, when checkpoint initiates, frequently this checkpoint is there, na? This checkpoint
Processor, yeah.
This checkpoint will initiate DB writer to write the dirty buffers to data files. For half an hour once, 15 minutes once, this checkpoint will initiates DB writer to write dirty buffers to data files. Third one, when there is no free space in buffer cache. That means if this buffer cache is full, then also DB writer writes to dirty buffer when there is no free space in buffer cache. In these three conditions, a DB reader will write all the dirty buffers to data files. Is it clear? Now, when this log writer will write redo-log buffer information to redo-log files. Log writer. On commit. When you say commit, immediately this redo entries will go to redo log files. Second one, every 3 seconds, all the redo entries will go and sit in your redo log files. Very importantly, before DB writer. Yes or no? DB writer is writing only when 1/3 is full, when there is no free space, when checkpoint initiates. But redo-log buffer is information. Immediately, when you say commit, immediately it is going to redo-log files. For every 3 seconds, it is going to redo-log files. Before DB writer also it is writing. For example, I am creating one sales order. Okay, SCN 100 generated. The same SCN 100 generates here, right? 100. Immediately this data will go to data files or not? This data from buffer cache will go to data files, yes or no? Will it go immediately?
No, sir. After one
No.
turn only.
These three conditions has to meet. One of the three conditions has to meet. But what about this? Immediately that sales order is going to your redo-log files. SCN 100 redo-log files. Now SCN, another transaction, 101. Here also 101 creates, right? 101. Immediately it will go to your physical files, 101. Like that, 110. 10 transactions happened. 110 also happened. Here also we'll get 110 and immediately all these files will go to redo-log files. From 100 to 110 is saved in data files or not? No, not yet saved. Why? No condition has met. But here 100 to 110 already went to your hard disk, redo-log files. Now suddenly power down. My system crashes. Power down means this is a RAM memory, right? RAM memory is a volatile memory. All your memory will gone. How you recover your data? In this data files you have up to SCN 99 only. But what is current running SCN? 110. From where you recover your data? From redo-log files. And who is aggressive here? DB writer or log writer? Who is aggressive? Log writer is aggressive.
Log writer.
Immediately when you say commit, it is going to physical files. Or else for every 3 seconds it is going before DB writer. But this 1/3 is not full. So don't go to data files. Checkpoint not initiated. Okay, still the data is in your RAM only. And there is a free space. Still the data is in your RAM only. But what about your data files? Only up to 99 you have. For redo-log files, up to 110 you are having. Now suddenly power gone. This is all RAM memory, na? When your power gone, system shut down, what happens? All your RAM will be cleaned. It is a volatile memory, not a non-volatile memory, right? It is a volatile memory. It is not permanent. So how can you recover? What about these 10 transactions? 11 transactions? 11 people booked their mobiles. All this data gone. The original data is my data files. Up to 99 only I have. To recover your database, you need redo log files. If these redo files are filled, from where you will recover? You have archive log files. Now these files will be archived. If these 200 MB, 200 MB, two files are filling up within 6 to 7 transactions, the remaining 100, 110, 101, 102, 103 will be backed up already to archive log files. Archive log files are also offline redo log files only. So if your redo entries are safe, your database is safe. Who is aggressive, DB writer or log writer? DB writer, log writer is aggressive. Is it clear?
Yes, sir.
Any doubt here?
Yes.
No.
So if you create a sales order, immediately the data is going to your redo log files, not data files. Later it will go to data files. Yes?
సార్ నిన్న చెప్పిన దానికి ఈ రోజుకి సంబంధం ఉంది కదా సార్?
Yes. Nadi.
దెన్ డాటా కాపీ రెడ్ లాగ్ కదా సార్?
Yes.
Data files యొక్క copy
yes,
redo log.
data copy redo log files. Yes, exactly. The data is generating, redo entry is generating. The data is going late to your physical disk. But that redo entries are, redo entries are going fastly to your physical disk.
Done, sir. Done. Clear.
Clear? Yeah. Okay, I'll come to that later. Next part is shared pool. One is buffer cache, second one is redo log buffer. Means this is some small memory area in your RAM. This is one memory area in your RAM. This is third one, shared pool. This shared pool is used for parsing of the data. Parsing will happen in your shared pool. What is the meaning of parsing? Parsing means syntax check plus semantic check. What is the meaning of syntax? Syntax means structure. Structure of the statement. It will check SQL, your data, what statement you throw to your database. Every database will understand SQL only, right? So when you throw an SQL statement, it will check the structure. SQL is a structure query language. The structure should be good. So the syntax, the structure it will check, and semantic check, the meaning of the statement. The statement should be meaningful and it should have structure. That means you should throw a valid SQL statement. Whether that SQL statement is valid or not, it will check by your shared pool. Shared pool, what happens? Parsing. That activity is called as parsing. When you hit one, for example, select a star from employee table. If it is a valid statement or not, that checking is called as parsing. In shared pool, parsing will happen. Okay, when you throw an SQL statement, internally the system also calls some SQL statements. That statement's parsing data will be stored in your dictionary cache. Shared pool contains two things. One is library cache, second one is dictionary cache. User executed SQL statements parsing data is stored in library cache. The system internally executed statements parsing data is stored in dictionary cache. For example, if you write one SQL command and say enter, then that will be stored, that parsing data will be stored in library cache. System also internally calls some tables to give you that output. That SQL statements parsing data is stored in your dictionary cache. If you observe here, which size I draw bigger? Shared pool. Why? Means there is a intention. If your shared pool size is more, it will store more parsing data. For example, 1000 SQL statements parsing data is stored in your library cache. If a user throws the same SQL statement one more time, it won't do parsing. Already parsing is done for that SQL statement. Immediately it will throw the result. So the time taking to do syntax check and semantic check is reducing here. That is the reason you should give your shared pool size generously. If you give shared pool size generously, more parsing data will be saved there. And whenever you execute throw some SQL statement, immediately it will throw you the result without doing parsing. Why? Already that statement parsing. Generally we use same SQL statements, right? Alter database command, and select star from that table, select star from this table. It won't do syntax check and semantic check one more time. So that time we are reducing by increasing shared pool size. Is it clear with everyone? Please relog in. Only 1 minute left. So if the shared pool size is more, your database performance will be good. Why? It is storing more parsing data. So user executed SQL statements parsing data will be stored in library cache. System internally executed SQL statements parsing data will be stored in your dictionary cache. These three are different memory. Buffer cache stores data, Redolog buffer stores Redo entries, and shared pool is for your SQL statements parsing data. Another memory areas are large pool, Java pool, stream pool, and fixed SGA. Large pool is for PL/SQL statements execution area. PL/SQL statements. So Oracle database is having PL/SQL programs, right? If you want to execute any PL/SQL program, at that time it will use this memory area to execute your PL/SQL programs. And this the same way Oracle also have some Java programs. Java programs execution time it will use Java pool area. For PL/SQL programs execution, it will use this area. For Java programs execution, it will use Java pool area. If you run any Java program on your Oracle database, Oracle and Java both are same, right? Java belongs to Sun Microsystems. Later it is acquired by Oracle. Now this Oracle database is having some Java programs also into that. Now Oracle Java, not Sun Microsystems Java anymore. Stream pool is for data replication. Data replication. Replication means the copy. If you want to copy some data from this database to that database, so it will use that stream pool area. It will use stream pool area. First the data will be loaded from hard disk to this stream pool area, from this stream pool to target database stream pool area to target database physical files. For data replication, it will use a stream pool area. And fixed SGA is a small part in your SGA which is having information about your all memory areas. Fixed SGA is a small area in your SGA. This is all SGA, system global area, contains these many memory areas. Now my total SGA size is 6 GB. Means if you add up all these memory areas, the total will be 6 GB. So one of the memory areas fixed SGA, it is having information about your SGA. And remember, here we are having some mandatory memory areas. We are having some mandatory memory areas. What are they? Your buffer cache. Your buffer cache is mandatory. Without buffer cache, no database. Your Redolog buffer is mandatory. And shared pool is mandatory. Fixed SGA is mandatory. Means these four memory areas you have to define in your parameter file. Which file was P file? You have to define buffer cache size, Redolog buffer size, shared pool size, and fixed SGA. These four are mandatory things. And this is your wish. You can give large pool size, Java pool size, stream pool size, yes or no. If you don't give large pool size, Java pool size, stream pool size, at the time of PL/SQL statements execution, Java programs execution, and data replication, it will use shared pool. If you don't mention these three sizes, it will use shared pool size, shared pool area to execute PLSQL programs, to execute Java programs, to do data replication, it will use shared pool area. Is it fine with everyone?
Yes, sir.
Everyone?
Yes, sir.
Any doubt in this? If somebody asks you Oracle architecture, this is your Oracle's architecture. Some people will call it as a SGA architecture. SGA architecture and Oracle architecture both are same. This is what SGA structure only, na? And we are having DB rater processes. DB rater, log rater. You know DB rater. When DB rater writes, when log rater writes, you know. And what is checkpoint? The third one is checkpoint. What is the duty of checkpoint? The first duty, you know. What is the first duty of checkpoint? Initiates. Checkpoint initiates DB writer to write dirty buffers to data file. This is one of the duty, right? DB writer, checkpoint initiates a DB writer to write dirty buffers to data files. That is one duty. The second duty is checkpoint writes SCN information info to data file headers. What SCN number is running? Who that information it will write to data file headers. Who will write? Checkpoint will write. And third point writes SCN info and log sequence number info to control file. Yesterday I told you control file contains exact path and location of your data files, redo log files, archive log files. Along with that, current running SCN information, current running log sequence number. How control file it is updating that information? So this checkpoint is continuously writing current information to your control file. These are the checkpoint duties. If checkpoint is not running, your current running information, your data files SCN information and control files SCN information should be matched. Otherwise, your database will not open. So checkpoint is very important. Without checkpoint, no dirty buffer will go to DB writer. No SCN information will be written to data files. Control files are not updating. Lot of havoc is happening if checkpoint is not running. That is the reason I told you these are all mandatory things. If DB writer is not running, your data files won't update. The heart of your database is your data files. So DB writer mandatory. If log writer is not working, log writer is not running, and suddenly your power down happened. How can you recover the latest data which is not updated into data files? So no use. Log writer also mandatory. Checkpoint also mandatory. The second one is SMON. Fourth one is SMON, system monitor. What this will do? System monitor will do. It will do the recovery. Automatically it will try to recover the system whenever the power failure happens. For example, if a system suddenly crashes, how you recover? Automatically, SMON try to automatically recover your database by using redo log files. So that is SMON's duty, automatic recovery. And fifth one is PMON. What is PMON? It is a process monitor. All these processes, DB writer, log writer, checkpoint, SMON, PMON, the leader for all these processes is your PMON. The first process which will start in this 5 is PMON. It will start and it will kick all other processes. If any of the mandatory processes are stopped, then PMON will crash your system. If DB writer is not running, PMON immediately stop your database. Why? Data files are mandatory. Log writer is not running, so redo log files are mandatory. PMON will start your system. Checkpoint, everything is mandatory here. So if any of the processes, mandatory process are not running, then PMON immediately crash your system. SMON, PMON, DB writer, log writer, checkpoint. These five are mandatory background processes for your Oracle database. There are some optional processor also there, archiver, recoverer, and some. There are so many 30 plus background processor there, but these five are mandatory. So without occupying RAM memory, without starting these processes, your instance is not started. The combination of your RAM has to be allocate, your RAM has to be give 6 GB RAM to accommodate memory for these memory areas, and your processes has to start these five processes. The combination of these two is called as instance. Oracle instance is started. Now today we started Oracle instance. How this instance will read these data files, log files, and how these physical files which are present in your hard disk are running by this instance. We'll see tomorrow. We'll combine these two things tomorrow. Buffer cache information is going to data files. Redolog buffer information is going to log files. Who is writing buffer cache information to data files? DB writer. Who is writing Redolog buffer information to log files? Log writer. And what are the duties of these all processes? So these processes, this memory, the combination of this is called as instance. First of all, to start your database, you need to start your instance. RAM has to provide some memory to accommodate memory for all these memory areas, and your processes has to start these processes. When the combination of these two is called as instance. After starting instance, you can access this data files, log files, actual data which is present in your hard disk. Any doubts here?
సార్ మీ నోట్స్ ఒకసారి ఓపెన్ చేయరా, స్క్రీన్ షాట్ తీసుకుంటాం.
My screen is not visible.
నోట్ ప్యాడ్.
My notepad. Is that notepad? This one, no? Yeah.
This one, sir, not this one. That means now.
Not this one, expression one. Paint.
Paint
one.
Yeah. Please take image and post in the group so that everyone can refer this.